Hey pirates, welcome back. Let's talk today about classifying triangles. I think we all know what a triangle is, and I'm sure we're aware that there's a lot of different triangles. So the question is how do we name triangles? How do they get their names? How do we determine what types of triangles we are dealing with? And with that, we're also going to talk about the missing angles of triangles because those are important in helping us classify them as well. Okay, so let's get right into it today. I asked this question, what is a triangle? And I don't say it in a way that I don't think you know what it is, but really that we want to start to get into the specifics of what makes shapes what they are. I think many of us know that a triangle is a three-sided figure. That's not probably rocket science to us. Okay, those three line segments, we talked about the word line segments yesterday, are CA, AB, and BC. They make up that triangle. And we also call those points there C, A, and B vertexes. So we would say that a triangle also has three vertexes to it. Okay. Vertex A, vertex B, vertex C, whatever you want to call it. Okay. Now, another thing that we seem to know from when we're younger is that the three angles inside of any triangle, we call those interior angles, always add up to be 180 degrees. The sum of the angles of a triangle are 180 degrees. That's what we call the triangle sum theorem. And that's true for all triangles. Doesn't matter what type of triangle you're looking at. The sum of the angles inside of a triangle is 180 degrees. That is true. And when it comes to naming these triangles, you name them by their vertexes. So I could call this triangle CAB if I wanted to. I could call it BAC if I wanted to. In fact, I could even call this triangle ABC. So there's a lot of different ways that you could name this triangle, but you name it by the vertexes. Okay, with that in mind, let's start to look at some of the problems that might involve triangles. Now, we know that this thing is a triangle that we're looking at because it's got three sides to it. It's got the three line segments, the three vertexes. Now, I notice that it's got three angles, and the question is asking me to find the measure of each angle. Now, if you didn't know the triangle sum theorem, you probably think it's impossible to know the measure of the angles because I don't know what x is. But because we know the triangle sum theorem, we know that these three angles must add up to be 180 degrees. So x plus 7 plus 3x minus 7 plus x plus 10 is equal to 180. Now, I just simplify this left-hand side. I do all the like terms there. I have an x, a 3x, and another x. It's going to give me 5x. I have positive 7, negative 7, and 10, so that's going to give me plus 10 here. And now I just go ahead and I solve this equation. So subtract 10 on both sides. In fact, let me pause the video and I'll come back once I have the answer. Okay, so once you solve the equation, you end up with x is equal to 34. But remember, 34 is not the measure of any of those angles. You actually have to take 34 and substitute it back into x in each one of these angles to find out what they are. So take a second. We can go ahead and do that. When I do that, let me pause the video and we'll come back with the answer. Okay, once I've substituted 34 back into each one of those x's, I end up with 95 degrees for one angle, 41 for the other, and 44 for angle B. And when you add them all up, you do get 180 degrees. And there you have it. That's how you can find the missing angle of any triangle. Okay, so long to that. Now, let's get into really what I want to talk about today, classifying triangles, meaning how do we name them? So triangles can be named basically two different ways, by their sides or by their angles. Okay, so we have what we call a scalene triangle. That's what you see in this picture here. This triangle is considered to be a scalene triangle because none of its sides are congruent. None of their sides are the same. Okay, meaning AC is a different length than AB, which is a different length from CB. So for that reason, this thing is scalene. Now, you'll learn in future lessons that because all the sides are different, all the angles are different too. So what makes something scalene also is that all of its angles are different. So a scalene triangle can be called scalene for two reasons. One, because all of its sides are different, or two, because all of its angles are different. Okay, now, some of you are probably familiar with something called an isosceles triangle. Now, what makes an isosceles triangle special is that it has two congruent sides, two sides that are the same length. Okay, we use the word congruent to talk about something that's equal in size. So, an isosceles triangle, two of the sides are going to be congruent. And again, I told you this, you'll learn this in future lessons, because two of the sides are congruent, those angles that are opposite them are also congruent. So it's going to have two equal angles. Now, there's another piece there that talks about the altitude. We'll talk about the altitude in future lessons, but the altitude is this line that connects from the vertex, which is the A, down to the base of that isosceles triangle. And we'll talk about that on another day. But if AC is congruent, and we use this symbol to show congruent to AB, these angles are called base angles, and they are congruent to each other as well. Okay? So an isosceles triangle. Why is it isosceles? Well, maybe I find out that it's got two congruent sides. Or maybe I find out it's got two congruent angles. And that's what makes it isosceles. So we're classifying that by both its sides and its angles. Okay. One really famous one, the equilateral triangle. Equilateral, just in its name, it's got sort of that equal part of it. All the sides are congruent and all the angles are congruent. They all have to be 60 degrees because, as we talked about earlier, three angles of a triangle must add up to be 180. So there's an equilateral triangle. Now, just because I find that one angle in a triangle is 60 doesn't make it equilateral. Keep in mind, I could have one angle that's 60, another one that's 100, and another one that's 20. And that's not an equilateral. So make sure that in order to prove that something's an equilateral triangle, that at least two of the angles are 60, and that will therefore make the third one 60 as well. All right. Now, I know we've talked a lot about the angles, but really, I would say that I classified all these triangles based on their sides. If you want to classify triangles by their angles, we would call the angles these three different things. An acute triangle, that's a triangle where all the angles, all the interior angles, the angles on the inside are less than 90 degrees. So maybe something like 30, 80, and 70. Okay, a 30-degree angle, an 80-degree angle, and a 70-degree angle on a triangle would be considered a acute triangle because all the angles are less than 90 degrees. Okay, an obtuse triangle. That's a triangle where one of the angles is greater than 90 degrees. So maybe you have a 100-degree angle on a triangle, and then the other two might be, 40 and 40 or something. Now, somebody might ask, well, can I have more than one obtuse angle in a triangle? But if you think about that for a second, that's impossible, because if you have two angles that are over 90 degrees, then that triangle cannot have the three angles add up to be 180. So that can't happen. All right, and the third type of triangle that we name based on its angle is what we call a right triangle. And that's a triangle that has exactly one 90-degree angle in it. Obviously, it can't have more than one 90-degree angle, but in this case, is sometimes identified with a little box in the corner there. There's my 90-degree angle. The other two angles do add up to be 90. We say they're complementary. But again, those are terms you'll learn in a different unit. What you see there at the bottom is, and you might be familiar with this from 8th grade, that's called the Pythagorean theorem. We'll do a unit on that, and that applies only to right triangles. Okay, clear off our screen here. We'll do one practice problem or two practice problems together, and then I'm going to let you guys go and work independently here. Okay, here we have a picture of a triangle, and it says solve for x and classify each triangle. Well, I might have an idea of what I think that triangle looks like, but until I find out what the measures of these angles are, I'm going to have no way of knowing what this triangle is. But I do know that the sum of the angles, let me use a color that we can see here, that the sum of the angles of a triangle must add up to be 180 degrees. So I'm going to set up that equation. Okay, and just like we did the other one, we'll simplify the left-hand side. 2x and 2x and x is 5x. Positive 10, negative 10, and negative 5 gives me negative 5 here. And then we go and solve that equation. All right, let me pause it. Okay, now you can see what I've done. I've solved that equation. I've gotten x is equal to 37. I've substituted 37 back into x for each one of those angles. And now I found out that the angles are 47, 64, and 69. And based on the fact that all of those angles are different, I can now conclude that this is a scalene / acute triangle. So I can identify it really specifically. Not only is it scalene because all the angles are different, but it's also acute because all of the angles are less than 90 degrees. Okay. Okay, one last one. And this one is kind of unique in that it says that in triangle ABC, angles A and B are in the ratio of 3:1. Oh, tells me that angle C is 2x plus 42. So it gives me that one. That's a nice expression. But A and B is in the ratio of 3:1. If you go back to your algebra days, you know that to handle that, just then say that if the angles A is 3 and B is in the ratio of 1, then just call A 3x and B 1x. That's all there is to it. So if somebody gives you a ratio like that, just write it as 3x and 1x. And then we just go ahead and we'll write our equation. 2x plus 42 plus 3x plus 1x is equal to 180. We'll solve that equation. We'll get x. We'll substitute it back in. Let me pause the video and do the work. Okay, so there you have it. When I solved it, I ended up with x is equal to 23. Substituted that x back in, and I got angle A is 69 degrees, angle C is 88 degrees, and angle B is 23 degrees. So once again, and it's just a coincidence, it just so happens that this is a scalene acute triangle. Scalene because all the angles are different, and acute because all the angles are less than 90 degrees. Now, if we plugged it in and let's say angle C came out to be 108 degrees, then that would be scalene, but it would be an obtuse scalene triangle. So just so happens that both came out to be the same, but there you have it. Identifying and classifying triangles based on their angles and their sides.